Here we are at example 2 from our 1.4 number 2 set of notes. We're asked to determine where h of x, which is equal to the cosine of x squared minus 5x plus 2, is in fact continuous. Now, if we look very, very carefully at this function h of x, we actually see a cosine on the outside part, and then our inside piece is this x squared minus 5x plus 2. And as a result, believe it or not, this is actually the composition of two different functions. So our cosine, you could consider to be our f function, and this x squared plus 2 would be considered to be our g function. So as a result, you can kind of see, hopefully at least, this composition of two functions. Now, because that's actually going to help us in determining where the continuity is, because we're going to say f of x is equal to the cosine function, cosine of x, is continuous. We know that from our pre-calc class that the cosine function is continuous from negative infinity to positive infinity. And we also see this polynomial g of x, which is equal to the x squared minus 5x plus 2. That's actually just a quadratic, and that's a polynomial. And that is also continuous on negative infinity to positive infinity. So because both of them are in fact continuous everywhere, then the composition of f of g of x, which is equal again to our h of x function, is equal to, or I'm sorry, is continuous, I should say. On negative infinity to positive infinity as well. So again, since both elements were continuous everywhere, the composition of those two functions would also be continuous everywhere. And again, that's a prime example really of our corollary that we just saw. So that coming from right here, dealing with continuity. All right. So again, that is example 2 from our 1.4 number 2 set of notes.